Hey, what's up, guys? Chung here again. And today, let's take a look at this LeetCode problem here, number 732. My calendar, number 3. It's I would say it's a like a medium, between medium and hard problem, and I think it's a very interesting problem comparing to the regular or normal like interval or meeting room problem. You know, same. Okay, so and this one it asks you to implement like a small class here, okay, where the book method will be called many times. I think here, uh, yeah, the book method will be called like at most 400 times, okay, and then basically it asks you to return like the most meeting rooms, not the meeting rooms, sorry, the most events, okay, so the most events that uh have the intersections, okay. So for example, this one here, and so when you call the book at the first time, right, so it's 10 to 20, okay, right? So it's 10 to 20, so which means the intersection is 1. Basically, I think it's just asking you to like what's the most meeting room you need, but in history, but not at the moment, okay? So this is a little bit tricky here. So in book 2 here, like 50 to 60, okay? So somewhere here, 60 to 50. And still, right, still there's should be only one intersection, right? And now 10 to 40, okay? So now we have 10 to 40, 10 to 40, okay? So now as you guys can see, we have two like bookings, right? Who is intersect with each other, okay, right? Now 5 to 15. Okay, 5 to 15 is here, right? 5 to 15. 5 to 15. Okay, and at this moment, right, see, we have three, right, which is this one. We have three bookings that intersect with each other. Now the next one is 510. So that's 510. Okay, so 510. But keep in mind here, right? No, notice here, like the 510, 510 only intersects with 515. Which is 2, right? But we're still returning 3 here because it's asking us to return the most k. Uh, Here I think the most k. Yeah, returns an integer k representing the largest integer such that there existing a k bookings in the calendar. Basically, it asks you to loop through to check all the history bookings, okay, and to find out uh, the most intersected uh, bookings, which in this case is still 3, right? Okay, and then 25 to 55, 25 somewhere here, 25 here, that's here to 55 is here, 25 to 55. Okay, so I think so this thing is still it's still like 3. Yeah, 1, 2, and 3. Okay, is this 3? No, actually it is 2. Okay, so for this 25 to 55 it's still 2 because 25 only intersects with this one, but these two they don't share the same like intersection. That's why for this one it's still 2, but we still have like 3 here. Okay, so I think you guys can see here. So what we really need is we just need to uh, keep the history for all the bookings. Okay, And every time when we have a new bookings here, we're gonna try to scan from the left to the end. Okay, and every time, because at the beginning, I was thinking that okay, I need to create a to list, basically. Uh, every time when I see a start here, right, I increase the count by one. Okay, we're gonna have like self. We're gonna starts right the list, and then I'm gonna have like ends list. Okay, and then I'm gonna try to sort this starts and end from smallest to the biggest, right? And every time when I see a starts, I increase the count by one, and when I see the ends, I decrease. Okay, so same thing here. Basically, when we see five here, right? So we have five and five, right? And then the count will be two. Will become two, right? And then when we see like a 10 here, right? So 10 here means that we're gonna decrease by one. So two will become one. And then we have another like 10 here, right? So now will become three. Now we have 15 here. So this this will become to two. 21, right? Yeah, and then when we see a 25, 2, and 41, 50, 2, uh, 55, 1, and then 60, 0. Okay, that's how the intersection looks like, right? So, and as you can see, the biggest one is 3. That's how we get the 3 here. But I was thinking about if I can use I was trying to use two lists here, but then the problem is that since uh, we need to sort both the starts and end, right? And then the start and end, they're integer in the range of like a huge number here. So basically, we cannot do the range from the smallest from zero to the biggest number to the last time of the end, which that will be too many for loop, right? So instead we should just loop through all the starting point and ending point. But with these two arrays separate, right? I mean, it will be hard, right? Basically, let's say we sort the starts and then we sort the end. We sort both the starts and end, and we can only use one of the list as a for loop, right? Let's say we use the starts and we have 5 5, which is good, and then the next is 5, the next starts is 10, right? It's 10 10. But then how can we use the starts to find the end here, right? That will be a kind of difficult. So instead, we should merge those starts and ends in into one into one like times, okay, into one array here. Basically, so every time when we have a start, we use the time, we plus one, right? And when we have an end here, right, we decrease that time by one. In that case, we can just use the time, this one array to represent both the starts and end, and still we sort it by the time. Then we can just simply loop through all the time spots, right, in this array, and then we can get the result we need here. Yeah, that's the basic thinking process here, and let's try to implement this thing here. Cool. So like I said, we're gonna have like times, right? And this is gonna be uh, like the integer and default is integer and it's a dictionary and cool. Mm, yeah, so self dot times, right, times start, we, we increase by one, and self dot times end, right, we decrease it by one. Okay, now we just simply do a sort, right? for time in sorted self dot times. Okay, and uh, yeah, we can have an answer here. It's 0. Okay, so uh, that's the answer. We need a current here. We need the current. We also need the answer here. Uh, yeah, it's current intersection here, and we have an answer here. Basically, uh, current intersection will be the self dot times dot t, right? And then every time we have an answer there, we update max dot current inter, right? And in the end, we simply return the answer. Yeah, I think that's pretty much it is. Okay. Yeah, cool. Let's submit. Yeah, cool. So accept it. All right. I mean, as you guys can see, the running time is not that good because we what's the time complexity for this, right? Let's say assuming we call this booking n times, right? And for every bookings will be n, right, times what? We do a sorting, right? We sort the times, right? That's going to be a n log n, okay, right? N log n. So basically, it's going to be a n square log n. Yeah, we sort it and then we do a for loop. For loop is it's just n, right? But still, it's a n log n, so which makes this solution n square log n. Okay, and I think if you use like Java, I mean in Java there's like a tree map, right, where you can basically where you can keep the sortings of the times while you're doing the insert, right? In that case, I mean maybe it's gonna be I think on. It's going to be a log n, maybe I'm not quite sure about that because here we need to sort it, right? Because we have to scan from the left to the right. I mean, or we can somehow like when we do the insert, when we do the mm, yeah, when we try to do the set here, maybe we can try to maintain like an order so that we don't have to sort it. But anyway, so the main idea for this for this problem is we just need to track up the boundaries. Basically, we track both the start and end point, right? And we use the same list or the same dictionary, okay? Because we need to scan both the start and end all together. That's why we're gonna use the same dictionary, and the difference is for the ending time, we decrease by 1, and to start we increase by 1. Okay, and after that we just simply keep track of the current intersections. Okay, and then we update the answer. Yeah, cool. I think that's pretty much I want to talk about for this problem. This is one of those like meeting room calendar problems. Basically, we have this different intervals, and then we have to do something with intervals. For the other like interval problems, like the meeting room number 2, it asks you to find the minimum meeting room, right? You need to hold all these like meetings or all these bookings, right? So for in that problem, what we did was it's very common, right, to sort by the start time. Okay, we sort by the start time, and then we use a priority queue, right? We use a priority queue to track off the end time here. Yeah, we use the So I think if I remember correctly, there were like a few regard different variations about this kind of problem. The first one is it asks you to find, okay, what's the most, how many given like given like a time range or something like what's the most or like given like two meeting rooms or some meeting rooms are like what's the most meetings this two meeting room or K meeting rooms can hold, right? So for that problem, what we did was we sort by the end time. We use a greedy method because to be able to hold as many meetings as possible, we want to start the meetings that end the earliest first, okay, and then basically we sort by the end time, okay, and then we just scan that the meetings from start to the end. And another variation is the meeting room number two, which is ask you to find the minimum, right? The minimum meeting room, right, to hold all those kind of meetings, right? So for that one, I believe we need to sort by the start time, okay? And we sort by the start time, and then uh, we use the priority queue, to hold the end time for all the meetings that we have already started. And every time when we have like a new meeting comes in, we check the priority queue to see if uh, if the earliest so if the current meeting start time is greater than any of the than the earliest ending meetings. If that's the case, then we know, okay, we can basically reuse the previously scheduled meeting room to host the current meeting, right? And then we keep doing it until the end. In the end, we simply return the length of the priority queue. Then that's the length of the priority queue will be our the minimum mm, meeting room we need. Actually, you know what? I will just do another videos for that meeting room number two problem to do uh, a more detailed explanation for this. Okay, cool, guys. I think that's pretty much I want to talk about for this problem. Yeah. Thank you so much for watching the videos, guys, and stay tuned. See you guys soon. Bye bye.